An owner of a 2018 Geely DHOEV 450 responded that the vehicle could not be started and the power battery malfunction indicator light was illuminated. Upon inspection by the service technician, it was found that the diagnostic instrument showed abnormal communication with the BMS, requiring a comprehensive inspection of the Power Battery Management System BMS. 1. We have 2 learning objectives for this course, which are: 1. Understand the power battery BMS signal acquisition components. 2. Check the BMS communication circuit. 2. We will learn today's content in the following 2 parts. Part 1. Recognizing BMS signal acquisition components. Single cell voltage acquisition module is a very important part of the power battery management system. The accuracy of the voltage value determines the system's judgment of the battery status information, and further affects the subsequent control strategy can be effectively implemented. On the other hand, the difference between the single cell may lead to the overall performance of the power battery degradation, which requires equalization control. The so-called equalization control is a set of procedures to protect each single battery from overcharging and overdischarging, and the electrical parameters are basically equivalent, which is integrated in the battery control unit BMU. BMS monitoring principle. BMS is a set of hardware and software control mechanism for real-time monitoring of power battery temperature, voltage, current and other electrical parameters, and is equipped with the functions of fault diagnosis, short circuit protection, leakage detection, SOC calculation and vehicle communication, etc. Its monitoring of the power battery mainly includes voltage detection, temperature detection and current detection. Geely DHOEV 450 Power Battery Single Cell Battery Voltage Acquisition Line. Battery High Voltage Distribution Unit BU. High Voltage Section Voltage Detection. Voltage detection of single cells or individual modules. 1. The single battery forms a battery module through a certain series parallel circuit, and Geely DHOEV 450 monitors the voltage of the single battery to understand the working status of the battery module and the working status of the power battery. The 2-wire harnesses B15 and B16 collect the potentials on the positive and negative electrodes of the single cell and transmit them to the acquisition board CSC2, as shown. The acquisition board summarizes and packages the voltage data and uploads it to the battery control unit BMU, as shown. 2. The voltage detection of the high voltage part of the battery high voltage distribution unit BU is mainly to detect the working status of the high voltage control auxiliary components. The CVS control unit collects the voltage of each auxiliary component through the 4 wiring harnesses X1, X11, X4, and X14, and determines whether the auxiliary components are abnormal. The voltage signal is then uploaded to the battery control unit BMU via the regional network CAN bus, as shown. Geely DHOEV 450 uses module detection to monitor the operating status of the power battery in real time. As shown in the figure, 6 single batteries constitute a battery module. Each module is equipped with 2 NTC negative temperature coefficient type temperature sensors. Temperature sensors close to the module in order to collect more accurate battery temperature. Temperature information is transmitted in the form of electrical signals to the Data Acquisition Integration Board CSC, which summarizes and packages the battery module temperature information under its jurisdiction and transmits it to the BMU via the CAN bus. Battery temperature protection. The power battery can work under the environment of -40 degrees centigrade, 80 degrees centigrade, But when the working temperature of the battery is controlled between 50 to 65 degrees centigrade by the thermal management system, the working performance and service life of the power battery can be significantly improved. When the BMS monitors that the power battery temperature exceeds the safety value, the control instrument alarms and initiates protective measures. Current sensor acquisition circuit. Geely DHAW-F450 current sensor is installed in the high voltage monitoring module BU. As shown in the figure, the red box is the current sensor, which is connected in series to the negative pole of the power battery. When a current is released or a charging current is present, the current sensor converts the detected current signal into a voltage signal, transmits it to the current sensor module CVS for analysis and packaging, and then sends it to the BMU through the CAN bus for decompression analysis and storage. Current sensor over current protection. In the process of charge and discharge, the current sensor in the BMS detects the charge and discharge current value in real time. When the current value exceeds the safe range, the BMS starts the protection measures. Different cars have different safety values of current. For example, the maximum charging current of Geely Emgrand car charger is 32 ampere and the maximum discharge current is 24 ampere. The maximum DC charging current of BYD E5 is 125 ampere and the maximum AC charging current is 40 ampere. Part 2. Checking the BMS communication circuit. 1. Vehicle CAN network. The full name is Controller Local Area Network Bus. Each electronic control unit is connected through CAN bus to exchange information with each other and form an automobile electronic control network. For example, the vehicle shown on the right has two CAN communication buses, Power CAN P-CAN and Multimedia CAN V-CAN. Among them, the Battery Management System BMS and the Vehicle Controller VQ. The P-Gear Control Unit PCU, the Driving Mode Switch DMS, and the Motor Controller form the Power CAN network. In the Power CAN bus, two termination resistors are set up with a resistance value of 120 ohm. Their function is to eliminate the current in the line after the signal transmission is completed, and the network communication is quickly transformed from explicit to invisible to improve the accuracy of the network data. The Power CAN bus communication uses twisted pairs of wires, one for the data bus high CAN H and one for the data bus low CAN L, and when the controller sends out the communication signal, the data of the two buses are mirrored each other. 2. CAN bus diagnostics. The CAN network is composed of several modules, and each module CAN line is connected in parallel. Any module lost communication, the diagnostic instrument will not be able to enter the module and there will be communication-related fault codes. Possible causes of malfunction. 1. Module failure, such as abnormal module operating voltage, module damage, etc. 2. CAN line failure, loose plug connector, CAN line break or short circuit. 3. CAN line termination resistor mismatch. Detection methods. 1. Using an oscilloscope to detect signals passing on the Power CAN bus. The signals passed on the CAN bus can be monitored using the oscilloscope dual channel input, with the start switch set to the on block. The voltage signal on the Power CAN H line is 2.5 to 3.5 volt, and the voltage signal on the CAN L line is 1.5 to 2.5 volt. 2. Measuring bus resistance with a multimeter. The starter switch is placed in the off block, and the negative terminal of the lead-acid battery is disconnected. Measure the resistance at the bus terminals of the diagnostic interface. Geely DHAW-F450 power bus at the diagnostic interface terminals 3, 11. The normal resistance value of about 55 to 63 ohm. If the resistance value is shown to be about 110 to -125 ohm or does not lead to indicate that the CAN bus may be disconnected fault, It is necessary to measure the bus segments of the line according to the circuit diagram, whether the line is disconnected. In this course, we have studied the abnormal fault diagnosis and maintenance of power battery network communication from the previous two aspects. I believe you have a good understanding of the whole knowledge. In the next class, we will learn the operation of abnormal fault diagnosis and maintenance of power battery network communication in detail. Thank you very much.